This is SpaceTime Series 27, Episode 66, for broadcast on the 31st of May 2024. Coming up on SpaceTime, a glitch aboard the BepiColombo's spacecraft bound for Mercury, exploring the unexplored regions of Venus, and an explanation for stars that mysteriously suddenly vanish. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The joint ESA-JAXA BepiColombo's spacecraft has experienced a sudden glitch, which is preventing the probe's thrusters from operating at full power. BepiColombo's a three-part spacecraft consisting of two scientific probes and the Mercury transfer module. The three sections are designed to separate from each other as part of the mission's Mercury orbit insertion operation. The solar arrays and electric propulsion system on the Mercury transfer module are used to generate thrust during the spacecraft's complex cruise phase from Earth to Mercury. However, as BepiColombo was scheduled to begin its next maneuver in late April, the transfer module failed to deliver enough energy to the spacecraft's ion thrusters. BepiColombo's flight control team, working at ESA's Mission Control Center in Darmstadt, Germany, were able to eventually restore about 90% of the spacecraft's thrust capabilities. However, the transfer module's available power is still less than it should be, and so full thrust cannot yet be restored. Mission managers' current priorities are to maintain stable spacecraft propulsion at the current power level and to estimate how this will affect upcoming operations. Meanwhile, a second team are working to determine the root cause of the problem and to try and maximize the amount of electrical power available for the ion thrusters. Now, if the current power levels can be maintained, BepiColombo should arrive at Mercury in time for its fourth gravity assist in September. The final orbit insertion at Mercury is slated for December 2025 and the start of routine science operations for early 2026. BepiColombo's array of scientific instruments are designed to study Mercury's composition, its atmosphere, its magnetosphere, and its history and evolution, and to address long-standing questions about its formation and the evolution of the solar system. This report from ESA TV.
A collaboration between ESA and the Japanese space agency JAXA, BepiColombo consists of two scientific orbiters, a transfer module to propel them to Mercury, and a sun shield. Protected by hand-stitched ceramic thermal blankets, the entire spacecraft is 6.5 meters high. Designed to withstand temperatures of up to 450 degrees Celsius, BepiColombo is one of the most technically and scientifically complex missions ever launched.
80% of our material needs to re-qualify for this mission because we hadn't tested before in that harsh environment. So it's a real challenge to go there and to bring two spacecraft in an orbit around Mercury.
The first challenge is getting to Mercury. Flying directly isn't an option. The sun's gravity means any spacecraft would be going too fast to make it into orbit. Instead, BepiColombo will take 7 years to reach its destination, combining solar electric propulsion with a total of 9 flybys of Earth, Venus and Mercury.
When we fly, we constantly brake against the sun because we fly into the inner side of our solar system. And when you fly towards the most heaviest element there, you constantly accelerate. We don't want that. This is why we decelerate.
Once they arrive at Mercury in late 2025, the orbiters will separate from the transfer module to begin their comprehensive scientific mission in 2026. With its 11 instruments, ESA's Mercury Planetary Orbiter will study the surface and internal composition of the planet. Meanwhile, JAXA's Mercury Magnetospheric Orbiter's 5 instruments will study the planet's magnetic field. Together, the orbiters will not only reveal more about Mercury, but also the history of the inner solar system.
Because Mercury is not tilted like Earth, it's spinning almost in the orbital plane. Therefore, there are some craters on the poles which never see sunlight. And in these craters, we found water ice. And this water ice could be stable over millions and billions of years. And that's a fantastic thing also about Mercury.
And in that report from ESA TV, we heard from BepiColombo project scientist Johannes Benkoff from ESA and BepiColombo project manager Ulrich Reinenhaus, also from ESA. This is Space Time. Still to come, exploring the unexplored regions of Venus, and finally an explanation for stars that mysteriously suddenly vanish. All that and more still to come on Space Time. Now, while we're on the subject of BepiColombo, a fleeting visit by the spacecraft to Venus has revealed surprising insights into how gases are stripped away from the upper layers of the planet's atmosphere. A report in the journal Nature Astronomy claims that observations in a previously unexplored region of Venus's magnetic environment show that carbon and oxygen are being accelerated to speeds where they can escape the planet's gravitational pull. It's the first time that positively charged carbon ions have been seen escaping from Venus's atmosphere. These are heavy ions that are usually slow-moving, so astronomers are still trying to understand the mechanisms at play. It could be that an electrostatic wind is lifting them away from the planet, or they could be accelerated through centrifugal processes. Unlike Earth, Venus doesn't generate an intrinsic geomagnetic field in its core. Nonetheless, a weak comet-shaped induced magnetosphere is created around the planet simply by the interaction of charged particles emitted by the sun and the solar wind with electrically charged particles in Venus's upper atmosphere. Draped around the magnetosphere is a region called the magnetosheath, where the solar wind is slowed and heated. Back on August the 10th, 2021, BepiColombo passed by Venus on a gravity assist maneuver designed to slow the spacecraft down and adjust its course towards its final destination of Mercury. In the process, the probe swooped through the long tail of Venus's magnetosheath and emerged through the nose of the magnetic regions closest to the Sun. Over a 90-minute period of observations, BepiColombo's instruments measured the number and mass of charged particles it encountered, capturing information about the chemical and physical processes driving atmospheric escape in the flank of the magnetosheath. Early in its history, Venus had many similarities to the Earth, including significant amounts of liquid water. But interactions with the solar wind have stripped away the water, leaving an atmosphere composed mainly of carbon dioxide and smaller amounts of nitrogen and other trace gases. Previous missions, including NASA's Pioneer Venus Orbiter and ESA's Venus Express, have made detailed studies of the type and quantity of molecules and other charged particles that are being lost into space. However, the mission's orbital paths have left some areas around Venus unexplored, and so many questions have remained unanswered. The data for this study were obtained by BepiColombo's mass spectrum analyzer and its Mercury ion analyzer during the spacecraft's second Venus flyby. The two sensors are part of the Mercury Plasma Particle Experiment instrument package, which is carried on the JAXA-led Mercury Magnetospheric Orbiter. Mass Spectrum Analyzer's principal investigator, Dominique Delcourt from the Plasma Physics Laboratory, says characterizing the loss of heavy ions and understanding the escape mechanisms at Venus is crucial to understand how the planet's atmosphere's evolved and how it's lost all its water. Europlanet Spider space weather modelling tools then enabled researchers to track how the particles would have propagated through the Venusian magnetosheath. Recent results suggest that the atmospheric escape from Venus cannot fully explain the loss of its historical water content. Over the next decade, a fleet of spacecraft will investigate Venus, including ESA's Envision mission, NASA's Veritas Orbiter and Da Vinci probe, and India's Shukran Orbiter. Collectively, these spacecraft will provide a comprehensive picture of the Venusian environment from the magnetosheath down through the atmosphere to the surface and interior. This is Space Time. Still to come, finally an explanation for stars that mysteriously suddenly vanish, and the June solstice, the spectacular Sombrero Galaxy, the heart of our own galaxy, the constellation Sagittarius, and the Taurus meteor shower are among the many highlights of the June night skies on Skywatch. Astronomers are showing new evidence of how massive stars can simply disappear, turning into stellar mass black holes with a whisper rather than a scream. Known as complete stellar collapse, the mysterious phenomenon involves the sudden disappearance of a massive star without the usual supernova explosion. The star just appears to suddenly vanish from the night sky. See, usually when stars 8 or more times the mass of our Sun run out of the nuclear fuel needed to trigger fusion, the process that makes stars shine, they undergo core collapse, with the entire mass of the star crushing down onto the stellar core. This triggers a huge explosion called a supernova, which is bright enough to outshine an entire galaxy. What's left behind is usually a tiny superdense object called a neutron star, just a dozen or so kilometers across, but containing so much compacted mass, a teaspoon of neutron star material would weigh billions of tons. Now, alternatively, an even more massive star would collapse beyond the neutron star phase, becoming a stellar mass black hole, an object of infinite density occupying zero volume. And gravity around such an extreme object is so intense, nothing, not even light, can escape. The new research suggests that with enough mass, a star's gravitational pull can be so strong that during its core collapse process, no supernova explosion takes place. Instead, the star goes through what's called a complete collapse. The study's lead author, Alejandro Vigna-Gomez from the Niels Bohr Institute, says the discovery is linked to the sudden disappearance of brightly shining stars, which had interested astronomers for years. The study involved observations of an unusual binary star system called VFTS-243, located in the Large Magellanic Cloud, a dwarf galaxy orbiting the Milky Way. The VFTS-243 system comprises a large main sequence star and a black hole roughly 10 times the mass of our Sun, with the pair orbiting each other. Now, astronomers know the system contains a black hole even though it can't be seen because of the way the main sequence star is orbiting with the black hole around a common centre of gravity. Normally, evidence for supernovae, such as a natal kick, gravitational perturbations, gas bubbles, irradiated space, or debris clouds called supernova remnants, can be identified and measured for centuries after the event. And also, there's usually a neutron star at the heart of the remnant. But in the case of VFTS-243, there are no traces of a supernova. A natal kick involves the violent forces of a supernova directly affecting newborn neutron stars and black holes left by it because of the asymmetric emission of matter during the explosion. This kick causes the compact object to accelerate, pushing the neutron star up to 1,000 kilometers per second away from the location of the initial supernova event. The speed's expected to be less for stellar mass black holes, but still significant. Because the black hole in the VFTS-243 system only appears to have been accelerated to roughly 4 kilometers per second, it shows no signs of having received a substantial natal kick, as would be expected had it undergone a supernova. Also, the symmetry of the star system's orbit usually shows some signs that it had felt the impact of a violent supernova explosion because of the ejection of material that happens. But instead, the researchers found symmetry in the orbit. The orbit of VFTS-243 is almost circular, indicating there are no signs of large asymmetries during collapse. So the analysis all points to the black hole being formed immediately in the initial core collapse, with the energy mainly being lost as neutrinos. The results highlight VFTS-243 as the best observable case so far for the theory of stellar mass black holes being formed through total collapse. The VFTS-243 system opens the possibility for finally comparing a range of astrophysics theories and model calculations with actual observations. So undoubtedly this star system will be incredibly important for studying stellar evolution and collapse. This is SpaceTime. Okay, time now to turn our eyes to the skies as we check out the celestial sphere for the month of June on Skywatch. June is the fourth month of the year in the old Roman calendar. It's named after Juno, who was the wife of Jupiter and is also the equivalent of the Greek goddess Hera. Another belief is that the month's name comes from the Latin word juniores, which means the younger ones. June also marks the winter solstice in the southern hemisphere. And of course, it means the arrival of summer for our lucky listeners north of the equator, which this year happens at 6:50 in the morning of Friday, June the 21st, Australian Eastern Standard Time. That's 20:50 on the night of Thursday, June the 20th, Greenwich Mean Time, and 4:50 in the afternoon, US Eastern Daylight Time. The June solstice occurs when the sun reaches its most northerly point in the sky as seen from Earth, zenith appearing to be directly over the Tropic of Cancer. It all happens because the seasons are governed by the tilt of Earth's axis as it journeys around the sun every year. On the day of the June solstice, the Earth's south pole is tilted by 23.5 degrees away from the sun, so the sun rises north of east and sets north of west. When the south pole is tilted towards the sun, it's the southern hemisphere's summer. Between these two, we have the autumn and spring equinox. Variations in temperatures on Earth aren't determined by the Earth's orbital distance from the sun, but rather the angle of the sun's rays striking the Earth. In the summer, the sun's high in the sky and the rays hit the Earth at a steep angle. But in winter, the sun's lower down in the sky and the rays strike the Earth at a more shallow angle. In most parts of the world, seasons begin on the day of the equinox and solstice. However, in Australia, seasons begin on the first day of a specific calendar month: March for autumn, June for winter, September for spring, and December for summer. Okay, let's turn to the constellations. And almost directly overhead this time of the year, we have the spectacular constellation Virgo. The constellation Virgo is named after Virgo, the goddess of justice and the harvest in ancient Greek mythology, who used her scales to weigh good and evil. However, she became so disenchanted with the deeds of evil men, she threw away her scales and retreated to the heavens. Now, interestingly, the ancient Egyptians also associate Virgo with agriculture. There, she was the goddess Isis, who sprinkled heads of wheat across the sky, forming the Milky Way. To science, Virgo is a tightly packed region of space containing some 2,000 galaxies, all gravitationally bound into a giant galaxy cluster located some 60 million light-years away. Now, our own local group of galaxies, which is primarily bound by the Milky Way and Andromeda, are an outlying member of this cluster. Now, the Virgo cluster is the heart of the Virgo supercluster, one of the largest known structures in the universe, a massive galactic node in the large-scale cosmic web-like structure of the universe. The mass of the Virgo supercluster is so great that its gravity generates the Virgo-centric flow, causing our Milky Way galaxy, as well as Andromeda and all the other members of the local group, to move towards the supercluster at about 400 kilometers per second. That's despite the accelerated expansion of the universe over cosmic timescales. The Virgo supercluster is now thought in turn to be simply a lobe of an even bigger galaxy supercluster called Laniakea, the center of which is known as the Great Attractor. Despite the Virgo cluster's size, it's so far away it's hard to see without a decently sized backyard telescope. You'll need something at least 100 millimeters in diameter or larger. Directly overhead right now is the constellation Corvus the Crow. Greek mythology tells us that Corvus could talk to humans, but he was a lazy bird, and so Apollo took away his ability to speak and banished him to the heavens. One of the highlights in the constellations Virgo and Corvus is the spectacular Sombrero Galaxy, M104. Visible with a good pair of binoculars or a small telescope, this stunning spiral galaxy is seen almost edge-on, providing audiences with a spectacular backlit view of its galactic bulge stars and the molecular gas and dust lanes in its arms. M104 is located some 31 million light-years away, and it's moving away from our Milky Way galaxy at about 1,000 kilometers per second. A light year is 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. The Sombrero Galaxy has a diameter of about 50,000 light years, about 30% the size of our Milky Way. It's surrounded by around 2,000 globular clusters and has an active central supermassive black hole at least 1 billion times the mass of the Sun. Now, by comparison, Sagittarius A star, that's the supermassive black hole at the center of our Milky Way galaxy, is just 4.3 million times the mass of the Sun. Globular clusters are tight stellar balls comprising millions to billions of stars, which were either the central remnants of a smaller galaxy cannibalized by a larger one, or they were originally all part of the same stellar nursery formed at the same time in the same collapsing molecular gas and dust cloud. The brightest star in the constellation Virgo is Spica, a spectroscopic binary located some 250 light-years away. Spectroscopic binaries are pairs of stars so close to each other that they can only be separated using a spectrograph to determine the individual chemical makeup of each component. Looking about 20 degrees above the western horizon in the early evening this time of the year, you'll find the brightest star in the night sky, the dog star Sirius. Only the Sun, the Moon, and the planet Venus look brighter. To the northwest or right of Sirius from the southern hemisphere is another fairly bright star called Procyon, the brightest star in Canis Minor, the lesser dog. In Greek mythology, Canis Major and Canis Minor were Orion's two hunting dogs. Procyon is another binary star system, this one comprising a spectral type F main sequence white-yellow star, Procyon A, and a faint white dwarf companion, Procyon B. Main sequence stars are those undergoing core hydrogen fusion into helium. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, the most massive, most luminous stars in the sky are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F white-yellowish stars, followed by spectral type G yellow stars, that's where our Sun fits in, then spectral type K orange stars, and the coolest and least massive stars known are spectral type M red dwarf stars. Each spectral classification can further be subdivided using a numerical digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you can add a Roman numeral to represent luminosity. Now put that all together and our own local star, the Sun, becomes a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars but became brown dwarfs after burning off some of their mass. Brown dwarfs fit into a category between the largest planets, which are around 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are between 75 and 80 times the mass of Jupiter, or 0.08 solar masses. White dwarfs are the stellar corpses of Sun-like stars. Having used up their nuclear fuel supply, fusing hydrogen into helium in their core, these stars expand into red giants as they begin fusing helium into carbon and oxygen. However, Sun-like stars aren't massive enough to fuse carbon and oxygen into heavier elements, and so they turn off. Their outer gaseous envelopes then float off into space as spectacular objects known as planetary nebulae. What's left behind is a super-dense white-hot stellar core, about the size of the Earth, a white dwarf, which will slowly cool over the eons. The white dwarf Procyon b is about 0.6 times the mass of the Sun and has a diameter of around 8,600 kilometres. Located some 11.6 light-years away, Procyon a has about 1.5 times the mass and twice the radius of our Sun. Interestingly, Procyon A has about 7 times the Sun's luminosity. That makes it unusually bright for this type of star, and that suggests that it's starting to evolve off the main sequence after having fused nearly all of its core hydrogen into helium. It's expanding out to become a subgiant as it begins fusing core helium into oxygen and carbon and burning hydrogen into helium in a shell around the core. As it continues to expand, the star will eventually swell to somewhere between 80 and 150 times its current diameter, becoming a bloated red or orange giant. That'll probably happen within the next 10 to 100 million years. The two stars, Procyon A and B, orbit each other every 40.82 Earth years at an average distance of 15 astronomical units. That's about the distance of Mercury's orbit around the Sun. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. Looking to the north-northwest from the southern hemisphere this time of year, and you'll see the constellation Leo the Lion, looking more like a bunch of stars shaped like an upside-down question mark. Located 36.7 light-years away, Arcturus is a bloated, aging red giant, about 7.1 billion years old and nearing the end of its life. Having used up all its core hydrogen, it's now fusing helium into carbon and oxygen. This has caused the star, which is only slightly more massive than our Sun, to expand out to around 25 times the Sun's diameter, becoming about 170 times as luminous. It'll soon puff off its outer gaseous envelope as a planetary nebulae, exposing its white-hot stellar core and becoming a white dwarf. In Greek mythology, Arcturus was the guardian of the bear. This is a reference to it being next to the constellations Ursa Major and Ursa Minor, the greater and lesser bears. There's some indications that Arcturus could have a binary stellar companion, but the results are inconclusive at this stage. There's also speculation that it could have a large planet or substellar object about 12 Jupiter masses orbiting it. Now that's close to brown dwarf size, but again the research remains inconclusive. To the east, when viewing from the southern hemisphere this time of year, are the three bright stars in the constellation Libra, the Scales of Justice. They're visible about halfway, or about 40 degrees above the horizon. Now these also represent the claws of Scorpius the Scorpion, which is chasing Orion across the sky. The brightest star in the constellation Scorpius is Alpha Scorpii, or Antares, the Scorpion's heart. Easily seen with the unaided eye, the red supergiant Antares is located some 550 light-years away, and it's one of the largest known stars in the universe. It has about 18 times the mass, but 883 times the diameter of our Sun. Antares is also around 10,000 times more luminous than our Sun. Now, looking to the southeast from the southern hemisphere, and you'll see the constellation Sagittarius, the Archer. Sagittarius is important because it marks the direction towards the center of our Milky Way galaxy. In fact, located just 27,000 light-years away in the direction of Sagittarius is the home of the galaxy's central supermassive black hole, Sagittarius A star. To the ancient Babylonians, Sagittarius was the god Nergal, the centaur, a creature half man and half horse. By the time Greek mythology took over, Sagittarius was also carrying a bow loaded with an arrow, pointing directly towards Antares at the heart of Scorpius the Scorpion. The center of the Milky Way and its supermassive black hole Sagittarius A star lie in the westernmost part of Sagittarius. Sagittarius has many spectacular highlights. Alpha Sagittarii, or Rookbat, meaning the Archer's knee, is a spectral type B blue star. Located some 182 light-years away, it is 2.5 times the diameter of the Sun and is about 40 times as luminous. Astronomers think it's surrounded by a dense debris disk and has a newborn companion star, which is only just starting to join the main sequence. The brightest star in Sagittarius is Epsilon Sagittarii, or Caus Australis, the southern part of the bow. Epsilon Sagittarii is a binary system located some 143 light-years from Earth. The primary star is an evolved spectral type B blue giant, nearing the end of its life on the main sequence. It has about 3.5 times the mass of the Sun, almost 7 times the Sun's radius, and is radiating around 363 times the Sun's luminosity. It's also a strong X-ray source, and is spinning very rapidly with an estimated radial velocity of some 236 kilometers per second. The system also displays an excess of infrared radiation emissions, suggesting the presence of a circumstellar disk of dust. The second star in the system appears to be inside this debris disk. Astronomers think it's going to be a spectral type G yellow dwarf star with about 95% the mass of the Sun. Sigma Sagittarii, or Nunki, is the constellation's second brightest star. The name Nunki is Babylonian, however its meaning has been lost through the sands of time. It's thought to represent the ancient Babylonian sacred city of Urdu on the Euphrates River. Now, if correct, that would make Nunki the oldest stellar name currently in use. It's another spectral type B blue star, located some 260 light-years away. It has about 8 times the Sun's mass, about 4.5 times its radius, and some 3,300 times the Sun's luminosity. Zeta Sagittarii, or Acela, the armpit, is a binary star system located some 88 light-years away, and it's currently speeding away from our solar system. Astronomers think that it may have been as near as 1.5 light-years from the Sun around 1.4 million years ago. That would have made it an extremely close former neighbour. One of the stars in the system is a spectrotype A white giant, while the other is a spectrotype A white supergiant, the pair orbiting each other every 21 Earth years. The system's combined mass is about 5.26 times the mass of the Sun. Delta Sagittarii, or Caus Meridionalis, appears to be a double-star system located 348 light-years away and listed as an orange giant. Then there's Eta Sagittarii, another double-star system, this one located 146 light-years from Earth. The primary star is an aging bloated red giant on the asymptotic giant branch. That means it's no longer fusing hydrogen or helium in its core, and is instead fusing heavier elements in the core and burning hydrogen and helium in its shell. It's already expanded out to some 57 times the radius of the Sun and is now nearing the end of its life. The second star in the system is a spectrotype F main sequence white-yellow dwarf, which appears to be in a binary system with a primary star orbiting it every 1,270 Earth years. Pi Sagittarii, or Albalda, is a triple-star system located around 510 light-years away. The primary star appears to be another spectrotype F white-yellow giant, and it looks like it's just about exhausted its core hydrogen and is now moving off the main sequence and evolving into a red giant. Pi Sagittarii has two nearby companions, but we know little about them. Beta Sagittarii, or Arcab, the Achilles tendon, is a designation shared by two separate star systems, one around 378 light-years from Earth, the other 379 light-years away. Beta Sagittarii A is a spectrotype B blue dwarf star, while Beta Sagittarii B is a white-yellow giant. Lying near the very centre of the constellation is Nova Sagittarii, which was only discovered in 2015, and as the name suggests, is a nova, a white dwarf in a binary system which is constantly drawing material off a close orbiting companion star. Once enough mass reaches the surface of the white dwarf, the added mass will undergo a thermonuclear explosion, causing the star to briefly light up like a beacon and then slowly fade again over the following few weeks or months. The blast isn't enough to destroy the white dwarf, only the additional material it's picked up. Now, once the star's gone nova and the additional mass has been burnt off, the same cycle starts over again, and the process repeats itself on timescales ranging from every few years to tens of thousands of years. The Sagittarius constellation also hosts many star clusters and nebulae, including some of the best-known astronomical objects in the sky. These include the spectacular Lagoon Nebula Messier 8, a stunning pink emission nebula that's located 5,000 light-years away and measures 140 light-years by 60 light-years across. The central area of the Lagoon Nebula is also known as the Hourglass Nebula. That's because of its distinctive shape because of matter propelled by a massive star-forming region called Herschel 36. It's one of the few star-forming nebulae possible to see with the unaided eye. The Lagoon Nebula was instrumental in the discovery of Bok globules, more than 17,000 of which have now been found in the nebula. Astronomers believe these globules contain embryonic protostars destined to eventually become new stellar generations. Probably the most famous nebula in Sagittarius is Messier 17, better known as the Horsehead Nebula. It's located some 4,890 light-years away in a dense region of ionized atomic hydrogen. Also known as the Omega or Swan Nebula, it spans some 15 light-years in diameter and has some 800 times the mass of our Sun. It's considered one of the brightest and most massive star-forming regions in our galaxy, with a geometry similar to the Orion Nebula, except that we're seeing it edge-on rather than face-on. The open star cluster, NGC 6618, lies embedded in the nebulosity and causes gases from the nebula to shine due to intense radiation from all the hot young stars. Open star clusters are loosely bound groups of a few thousand stars which were originally all formed in the same molecular gas and dust cloud, but they're not as densely bound gravitationally as globular clusters. Open clusters generally survive for a few 100 million years, with the most massive ones surviving for maybe a few billion. In contrast, the more massive globular clusters exert so much stronger gravitational attraction on their members that they can survive for much longer, billions and billions of years. The nebula is thought to contain around 800 stars, including over 100 of the largest, most massive spectrotype O and B blue stars. More than 1,000 additional stars are also being formed in the surrounding molecular gas and dust clouds. And with an age of just 1 million years, it's also one of the youngest clusters known in the galaxy. The cloud of interstellar material which formed the nebula is roughly 40 light-years across and contains some 30,000 solar masses. Another spectacular sight worth searching for in Sagittarius is the Trifid Nebula, Messier 20. It's another large star-forming emission nebula containing many very young hot stars. Located between 2,000 and 9,000 light-years away, the Trifid Nebula has a diameter of approximately 50 light-years. The outside of the Trifid is a bluish reflection nebula, while the inner region is glowing pink thanks to ionized hydrogen. There are two dark bands dividing the Trifid Nebula into three regions or lobes. Hydrogen in the nebula is ionized by a central triple star, which formed in the intersection between the two dark bands, creating its characteristic pink color. Another star-forming region, NGC 6559, located some 5,000 light-years away, contains both red emission and blue reflection regions. The grouping of the Lagoon Nebula, the Trifid Nebula, and NGC 6559 are known as the Sagittarius Triple and are a spectacular sight to go searching for in the night skies. But it doesn't end there. Another stunning object, easily worth a look, is the Red Spider Nebula, NGC 6537. It's a planetary nebula about 8,000 light-years from Earth. It has a prominent two-lobe shape, possibly due to a binary companion or magnetic fields, and has an S-shaped symmetry, with the lobes opposite each other appearing similar. This is believed due to the central companion to the central white dwarf. The central white dwarf, the remnant of the original star, produces a powerful and 10,000-degree hot, 3,000 km per second stellar wind, which is generating 100 billion kilometer high waves of supersonic shocks, formed as the local gas is being compressed and heated in front of the rapidly expanding lobes. Atoms caught in the shock waves are radiating invisible light, giving the nebula its unique spider-like shape and also contributing to the expansion of the nebula. The star at the center of the Red Spider Nebula is surrounded by a dust shell, making its exact properties hard to determine. We think its surface temperature is probably somewhere around 250,000 degrees, although a temperature of up to 500,000 degrees can't be ruled out, and that would make it among the hottest white dwarf stars known. Looking directly south is the star Polaris Australis, or more accurately, Sigma Octantis, the nearest star we have in the southern hemisphere to the south celestial pole, and consequently the closest counterpart we have to the north star Polaris. However, Sigma Octantis is far harder to see than Polaris because it's much fainter. Located some 270 light-years away, it's an orange giant reaching the end of its life. Turning to the southwest and just above the horizon this time of year, we find Canopus, the second brightest star in the night sky after Sirius. It's located 310 light-years away and is the brightest star in the constellation Carina the Keel. Canopus is a supergiant, some 9 times the mass of the Sun and 71 times its diameter. The month of June also marks the first of 2 annual encounters with the Taurids meteor shower. The Taurids are generated as the Earth passes through the debris stream created by the comet 2P Encke, which itself is thought to be a piece of a larger comet that broke apart somewhere between 20,000 and 30,000 years ago, most likely following numerous interactions with the powerful gravitational field of the king of planets Jupiter. As their name suggests, the Taurids' radiant or apparent point of origin is in the direction of Taurus the Bull. The Taurids meteor shower is unique in that it's made up of larger, more massive material, pebbles instead of dust grains. Earth passes through the stream twice every year, once now in June, then again in October, called Halloween fireballs. The Taurids release material both by normal cometary activity and also occasionally by close encounters with the gravitational tidal force of the Earth and other planets. And this makes the Taurid stream of material the largest in the inner solar system. Now, since this stream of material is rather spread out in space, Earth will take several weeks to pass through it, causing an extended period of meteor activity compared to the much smaller periods of activity associated with other meteor showers. Included in the stream is a denser flow of gravelly meteoroids called the Taurid Swarm. Thought to be a ribbon of rocks, roughly 75 million by 150 million kilometres across. Occasionally, planet Earth passes through the larger meteoroids in the denser Taurid Swarm. In fact, one of the larger chunks of the Taurid Swarm is now thought to have caused the infamous Tunguska event in the skies over Siberia back on June the 30th, 1908. Astronomers believe the Tunguska event was the airburst of a 100-metre-wide meteor over the Tunguska River region of Russia, causing mass devastation and flattening over 2,000 square kilometres of forest into matchsticks. The blast was so bright it was enough to light up the night sky in London a third of the way around the planet. Tunguska remains the largest known Earth impact event in recorded history. It was considered a 1-in-1,000-year event, assuming a random distribution of events over time. But the new study suggesting the event may have been caused by a Taurus swarm meteor, and with the Earth passing through that swarm periodically, this tends to change those odds quite significantly. Now, if the study's correct, this swarm heightens the possibility of a cluster of large impacts on the Earth over a very short period of time. Further complicating matters, the June Taurids are actually two separate showers. The southern Taurids associated with the comet 2P Encke, while the northern Taurids originate from the asteroid 2004 TG10, an eccentric kilometre-wide asteroid classified as a near-Earth object and potentially hazardous asteroid of the Apollo group. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.